This video goes over the Algebra 2 Semester 1 exam review. This review will count as 20% of your exam grade. So it is very important that you complete, check, and correct this review, that you show all of your work and that you do really, really well on it, because this will count as part of your semester exam grade. Okay? We're very serious about this. We have found multiple times that the students who do really, really well on their review are the students who tend to do well on the exam, and we want you to do well on your exam. So please complete, check, and correct this review so that you are ready for that exam and you do very well on this review and, more importantly, on your exam. Now, before I do these problems, let me tell you that the intention of this video is not that you watch the entire thing multiple times, okay? I would recommend that you try the review and do the best you can in test-taking conditions without any notes, just doing your best on the review, okay? And then you check your answers to see if your answers are correct. And the ones that are not correct, you try to figure out how to get to that correct answer, okay? If you still can't figure that out, then use this video. I promise you that you will do far better on the exam by following that process than by passively watching this video even multiple times, okay? So without preface said, let's start these problems. Number 1 is to consider the expression 6x cubed minus 5x squared y minus 24xy squared plus 20y cubed. And 1a asks which expression is equivalent to this polynomial. And a through d looks like some kind of part of the way through factoring kind of an expression. Okay, so I'm going to be factoring this, and there's 4 terms, and the one method that I try if there's 4 terms is factor by grouping. Let's factor this as a group and this as a group. And in the first group, the GCF is x squared. Okay, so x squared times what is 6x cubed? It is 6x, and x squared times what is negative 5x squared y, and that would be a minus 5y. Okay, and then in this second group, this leading term is negative, so I pull it a negative. And let's see here, the GCF of 24xy squared and 20y cubed is a 4y squared. So negative 4y squared times what is negative 24xy squared, and it is 6x. And then, this is tricky. So negative 4y squared times what is a positive 20y cubed. Okay, now this must be a negative here, so that a negative times a negative is the positive that I see in plus 20y cubed. Okay, so 4 times what is 20? It's 5, and I have y squared already out, and I have y left. Okay, and now I'm going to compare with what I have over here, and it looks like this is the answer. Okay, now I'm going to leave that there because in part B, it asks which expressions are factors of this. I'm going to keep going in factoring this. Let me kind of scroll up a little bit, and I have that work already done. So let me just keep going and see what factors I get. So I have this and this are the same thing. I pull that out in front as a GCF of those two large terms, 6x minus 5y. And what I'm left with is this x squared minus 4y squared. Okay? Now, is there more that I can do? And actually there is. Because this right here, believe it or not, is the difference of squares, okay? X squared is something squared and 4y squared is something squared. So that's the difference of squares. Let me copy over this 6x minus 5y. Okay, and then I have the difference of squares. Now, what squared is x squared? It's x and x. What squared is 4y squared? It's 2y and 2y. And I got positive and negative. Okay, so let me find all the things that I have. I have this one. I don't have the first one because the sign is wrong. Letter C is one of them. And D has a 2 instead of 5. And so it looks like B, C, and E are the factors of this polynomial. In number 2, the expression 6 minus parenthesis 3x minus 2i squared is equivalent to what? Well, let's see what we get. So I have 6 minus 3x minus 2i squared is that times itself. Okay, so I'm going to simply expand this out. I'll leave my 6 minus there. I'll leave this in parentheses because that minus of this stuff is important, so I don't lose that negative. I'll leave it there with a parenthesis. 3x times 3x is 9x squared. 3x times negative 2i is negative 6xi. And negative 2i times 3x is again another negative 6xi. And negative 2i times negative 2i is a positive 4i squared. All right, so combining like terms inside this parenthesis, 6 minus, I have 9x squared. I'll combine these two together and get negative 12xi. Okay, and then I will remember that I squared is equal to negative 1. Okay, and that's because I is the square root of negative 1. So if I square that number, I get negative 1. And negative 1 times 4 is a minus 4. Okay, so now I take care of that 6 minus. I take care of this negative sign, and I distribute in this negative, so it changes all the signs. Okay, and then I again combine like terms. And I'll write it in standard form, 9x squared, and then my x term, plus 12xi, and then 6 plus 4 is 10. And so I look over here, and it looks like number 1 is my answer. Number 3, without graphing or solving, which equation has non-real solutions? Well, the way that we tell if an equation has non-real solutions without graphing or solving is by using what's called the discriminant. Okay, the discriminant is b squared minus 4ac. It's a thing inside the square root in the quadratic formula. And if that is less than 0 or negative, then we know that we have non-real solutions. So I'll basically plug these into the discriminant and see which one is negative. Here we go. So in letter A, 4 squared minus 4 times A times C is that, and I get 16 minus 4 times 2 is 8. 8 times negative 12 is negative 96, and 16 minus a negative 96 is 112, which is very positive. Okay, so this would not have non-real solutions, it would have real solutions. In letter B, it's not solved for 0 yet, so I need to subtract 4x from both sides, and I'll subtract a 12 from both sides, so I get one side equal to 0. So that, again, is written as 2x squared. 3x minus 4x is minus 1x, and then negative minus 12 equals 0. So now plugging this into the discriminant, I have negative 1 squared minus 4ac, and I get, let's see here, negative 1 squared is 1 minus 4 times 2 times negative 12 is, again, negative 96. Okay, and so 1 minus a negative 96 is 97, which is still positive. In letter C, I have 4 squared minus 4 times A times C, and I get 16 minus 96, which is negative 80, which is less than 0. So this one right here is negative. So inside the square root of my quadratic formula, it would be negative, and so I'd have I'd have non-real solutions. Let me just check D, because I like checking all of them. For D, it'd be 4 squared minus 4 times A times C. C is the constant term, and there is no C, so it's 0. Okay, so that 0, you get 4 times 2 times 0, and you get 16 minus 0 is 16, which is bigger than 0. So that one will also give you real solutions. All right, in number 4, what are the solutions to the equation 3x squared minus x plus 1 equals 0? And looking down here, I have radicals in all 4 of those, so I'm not even going to try to factor this. I'm going to go straight to the quadratic formula. And the quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a. So using 3 as A and 1 as B and 1 as C, I'll plug that in here. So I get negative B, which is a negative 1, plus or minus the square root. You have 1 squared minus 4 times 3 times 1, all over 2 times 3. So simplifying a bit, I get negative 1 plus or minus the square root. 1 squared is 1 minus 4 times 3 is 12 times 1 is 12. All over 2 times 3 is 6. Just a little bit at a time. Okay. And I think at this point I can separate these two into 2 different fractions. So I have negative 1/6 plus or minus the square root. 1 minus 12 is negative 11, and it's inside a square root. So I have the square root of 11, I, divided by, this is also divided by 6. And I get this as my 2 solutions. X is negative 1/6 plus square root of 11 over 6i, and negative 1/6 minus root 11 over 6i. So it looks like D is the answer. In number 5, we'll let p of x equal this polynomial. What is the remainder when p of x is divided by x minus x plus 1? So I'm going to use the remainder theorem. Okay, you could use synthetic division if you wanted to. I'm using the remainder theorem and plug negative 1 into this function. So I'm going to look at p of negative 1. And so plugging in negative 1 in for all the x's, I get that. And so simplifying a bit. Okay, so negative 1 minus 3 is negative 4. Negative 4 plus 10 is 6. 6 plus 24 is 30. Okay? And I get 30 right here. Number 6, given a of x is x to the 4th plus 2x cubed plus 4x minus 10, and b of x would be x plus 2, determine a of x over b of x in the form q of x is equal plus r of x over b of x. So basically, it's saying divide them, right? So divide the 2 and write it like this. Okay, this right here is x plus 2. That's in the x plus or minus some number format. I'm going to use synthetic division. So using synthetic division, the number I write out here, I switch the sign so I can make this one change, and then I can add from then on. Okay, I'll pull off the coefficients here. I have 1 and 2, and be very careful because there's a 0x squared that's not written. So a 0 goes here, and 4 and negative 10. Okay, so using our synthetic division rules, drop the 1 down. Negative 2 times 1 is negative 2. 2 minus 2 is 0. Negative 2 times 0 is 0. 0 plus 0 is 0. Negative 2 times 0 is 0. 4 plus 0 is 4. And negative 2 times 4 is negative 8. And negative 10 minus 8 is negative 18. Okay, this is the remainder. the negative 18's remainder. 4 is constant. This is the x term, x squared term, and x cubed term. So rewriting this into the form that they want, I have x cubed plus 4 minus 18 over x plus 2. That's what I was dividing by. So that's the form they wanted it in. Okay? And the other question down here is b of x a factor of a of x? And the answer is no. The remainder is not equal to 0. Okay? If the remainder was 0, then it would be a factor, but this is negative 18, which is not 0. In number 7, we are given that x minus 1 is a factor of this polynomial. Determine the value of k. Now, for this problem, it is much easier to use the remainder theorem and the factor theorem. Okay, maybe you can get there using long division, but it would not be very pretty at the end. So let's use the remainder theorem and the factor theorem, and I'll plug in positive 1 into the function. Now, if it is a factor, that means that the remainder is equal to 0. Okay, so now I have a pretty basic equation to solve. Let me simplify a little bit here. 2 times 1 cubed is just 2. 1 squared is just 1, so minus 8, plus k plus 5 is equal to 0. Okay, combining like terms, I have k, let's see here, 2 minus 8 is negative 6, plus 5 is negative 1 equals 0. Let's add 1 to both sides, and I get k is equal to 1. Number 8, when factoring to reveal the roots of the equation x, that equation, which equations can be used? Justify. Okay, and I'll justify it using the work that I'm going to do. So what I see here is kind of some factor by grouping. So let's see what happens. If I do factor by grouping, because there's 4 terms, in my first group I have x squared as the GCF. And so I get x plus 2. In the next group I have negative 9 as my GCF. And I have x plus 2 equals 0. And it looks like I have this one right here. Okay. Now the other one, number 2, looks to be what I would get is if I switched these 2 terms and did factor by grouping again. So let's look at that. So I have x cubed minus 9x plus 2x squared minus 18 equals 0. I just swap those 2 terms, and I'll try factor by grouping again. So this is my group and this is my group. In my first group, x is my GCF, and I have x squared minus 9. In my next group, I have 2 as my GCF, and that's x squared minus 9 equals 0. Okay, which is exactly what this says. So that is possible. Okay, if I go all the way out and I factor this all the way, then I get x squared minus 9 and x plus 2. Okay, and I notice that this term right here, this is plus and this is minus, so this is not one of my equations that can be used. Okay, so the answer is the first 2 only, and the answer is 1. In number 9, we're asked to find the completely factored form of this polynomial. Okay, now this has 6 terms. Okay, and my first instinct when I saw the problem was to combine like terms and then like to do synthetic divisions, like guess and check stuff. And I thought about it really, really hard, and I noticed that the reason it's in this form of like n to the 4th and then an n squared and then n to the 3rd, and like it's in this really weird order, and it's in that order to help you. I'm like, there's got to be a reason it's in this order, and that's because you actually can do factor by grouping with 3 groups, and it works out. Okay, the thing you've left over is the exact same thing in all 3. Okay, so let me show you that. In this first group, my GCF is n squared, and I'm left with n squared minus 9. Okay, in the second group, the GCF is plus 4n, And what I'm left with is n squared minus 9. Okay, seeing a pattern yet? In the next group, it's negative, so I'll plot a negative 12. And what I'm left with is n squared minus 9. Okay, you get the n squared minus 9 in every single group. And that means I can do factor by grouping with this 6-term polynomial. So I'll pull that n squared minus 9 into the front. What I'm left with is n squared plus 4n minus 12. And then this thing right here can be factored using the ABC method. And I have n squared minus 9. Actually, before I write that down, before I do that, n squared minus 9 is the difference of squares, because 9 is 3 squared. And I get n plus 3, n minus 3. Okay, this trinomial here can be factored using the ABC method. This is a simple method where I'm looking for two numbers that multiply to be negative 12 and add to be positive 4, and that would be positive 6 and negative 2 would multiply to be negative 12 and would add to be positive 4, and so I get plus 6 and minus 2. Now the order of the factors can be a little bit different. Let's see here. This, start at the very top, completely factored, so that's not completely factored. In number 2, the beginning looks good, the whole thing looks good. Okay. In number 3, I'm missing the plus term in one of these. In number 4, these signs are backwards. So it's definitely number 2. Number 10. Which expression is equivalent to 9 minus x over x squared minus 81? Okay, well, I'm going to first start off by factoring the denominator, and it looks like I have, it's a difference of squares, x plus 9 and x minus 9. Okay, so what I get is 9 minus x over x plus 9, x minus 9. Now, it looks like that the numerator and this factor right here are very, very similar, but they're kind of switched in the order. Okay, so we kind of switch the order so it looks more like that order, and I'll do a negative x plus 9 divided by x plus 9, x minus 9, and I'll factor out a negative 1 out of the numerator, and that puts us at a x minus 9, the perfect thing that I need for it to cancel out. Okay, so now that looks the exact same, this whole factor will cancel with this whole factor, and I get a negative 1 divided by x plus 9, which is this term right here. Okay, number 11, the expression 2 minus x minus 1 over x plus 2 is equivalent to which of these? Okay, now before I get started, I notice that they're all 1 plus or minus something. Okay, so I want to match that. And I'll match that by thinking about 2 as in 1 plus 1 minus x minus 1 over x plus 2. That x got looking really funky. Okay, so I kind of pull at that 1, and I'll see kind of what happens with the rest of it. Okay, let me find a common denominator with this 1 and leave kind of that first 1 by itself. Okay, the common denominator is going to be x plus 2. So I have 1 times x plus 2 over 1 times x plus 2 minus x minus 1 over x plus 2. Okay, simplifying some more, I get x plus 2 minus, okay, let's be careful here. This minus right here, let me distribute this negative into here and here, okay? This is commonly missed as far as that sign changing because I'm subtracting that whole rational expression. Minus x plus 1 over x plus 2. Okay, so I get 1 plus, let's see here, this and this cancel with a x minus x, so I get a 3 divided by x plus 2. It looks like that one is equivalent to the first one. In number 12, that expression is equivalent to which of these? And there probably is a way that I can kind of pull off a 1 and factor and stuff. I'm just going to do a straight up long division. Okay, that's, I think sufficient, for what I'm going to do. So if I use long division, I have 9x squared plus 0x minus 2. Okay, that 0x is going to be a placeholder for me. 3x times what is 9x squared? And it's 3x. 3x times 3x is 9x squared. 3x times 1 is 3x. And then I will change all the signs and add, and the 9x squareds cancel, and I have a negative 3x. Bring down my minus 2. And then 3x times what is negative 3x, and I have a minus 1. And negative 1 times 3x is a minus 3x. And a negative 1 times positive 1 is a negative 1. And again, I change all the signs and add. 3x's cancel. And I have negative 2 plus 1 is a negative 1. Okay? Now, that's the remainder. Okay, and the same thing I did before with synthetic division, I'll do now. And it's a minus 1 divided by the thing I was dividing by, 3x plus 1. This is what it's equal to. So 3x minus 1 minus, it looks like that one. All right, 13. We're supposed to write the following rational expressions in their lowest term. Okay, I will start by factoring the denominator so I can find my least common denominator. So this GCF is b, and I have a 2b plus 1. Okay, which means that is going to be my least common denominator. I'll multiply top and bottom of the second fraction by b so that I have the same denominator. So I get 9b minus 6 divided by b times 2b plus 1 minus 7b over b times 2b plus 1. Now, 9b minus 7b is 2b. So I have 2b minus 6 divided by b times 2b plus 1. Okay? Now, I could factor a 2 out of the numerator, 2b minus 6. But even if I did, I would not cancel with the 2b plus 1 or the b. And so I'll leave it like that. All right, number 14, this is division. And the way that I divide fractions is I multiply by the reciprocal, okay, or I keep, change, flip. And I get 4x squared minus 9. Let me write this over here a little bit. Over here. 4x squared minus 9 over x squared plus 3x plus 2 times, flipping this over, x squared minus x minus 6 divided by 2x squared minus x minus 3. Okay, and let's factor everything that I can factor, okay, which is most of this. Okay, so I get 4x squared minus 9 is the difference of squares. What squared is 4x squared? It's 2x plus 3 and 2x minus 3 divided by x squared plus 3x plus 2. Let's see here, x and x, because it's a simple ABC method. Two numbers that multiply to be 2 and add to be 3 is plus 2 plus 1 times, let's see here, x squared minus x minus 6 is, again, the ABC method. X and x, the simple ABC method. Two numbers that multiply to be negative 6 and add to be negative 1 is a minus 3 and a plus 2. Okay, now 2x squared minus x minus 3 is a little more complicated. Let me go over here actually and tackle that one separately. Okay, this is the more complicated ABC, and a times c is 2 times negative 3, which is negative 6. Okay, so two numbers that multiply to be negative 6 and add to be negative 1 is negative 3 and positive 2. We'll multiply by negative 6, and we'll add to be negative 1. So I can expand this, and I get 2x squared minus 3x plus 2x minus 3. And then I can factor by grouping, and I pull out an x, and I get 2x minus 3, and that has nothing, so it's plus 1, 2x minus 3. Okay, so what I get is by pulling that in front, I get 2x minus 3 times x plus 1. So over here, I'm going to write 2x minus 3 and x plus 1. Okay, so now it's my favorite part. Okay, we're going to cancel all kinds of stuff. So 2x minus 3 cancels with 2x minus 3. What else do I got? I got x plus 2 and x plus 2. And it looks like that's about it. So writing what's left, I have 2x plus 3 times x minus 3 divided by x plus 1 squared. And that's squared. The 2 didn't show up very well. Okay. Let me erase that and scroll up to do the next one because I might need some more space on that one. Okay, 15. What is a solution set of the equation? And then I have this rational equation. Show work to justify your answer. Well, I'll start by factoring the denominators. And the most important one is this x squared minus 2x. And there's a GCF of x, and I get x minus 2. Okay, and that will be my least common denominator. So let's write this down. I have 10 over that common denominator plus this second term. What I need that the other one has, this one doesn't, is x minus 2. So multiply top and bottom by x minus 2 so that those two have the same denominator. Okay, this last term is missing an x, so I need to multiply top and bottom by x so that I get a common denominator. Okay, so now that I have a common denominator, I'm going to focus on these numerators. Okay, that this will be true when the numerators, when that equation is true. So I have 10 plus 4 times x is 4x. 4 times negative 2 is negative 8 is equal to 5x. Now let me subtract 4x to both sides. And 10 minus 8 is 2. 5x minus 4x is x, and I get x is equal to 2. Okay, now before I even box this, before I celebrate that I'm done, I have to check that 2 is not an extraneous solution. Okay, and the thing that could go wrong in this problem is dividing by 0. Okay, and right here is the easiest place to see it. If I plug 2 into x, then I get division by 0 there. Okay, it also happens here as well, by the way. Okay, this cannot be the solution because it's extraneous. Okay, so if there was a solution, it'd be there, but it can't be there, and so there are no real solutions for this problem. Okay, number 16. Consider the following system of equations. Okay, in A, we are to complete the square of y is equal to x squared minus 6x plus 3 and write this equation in vertex form. Okay, so what I do is I look at the first two terms, x squared minus 6x. I'm going to leave a space and put plus 3 out here. Okay, because I want to make this right here into a perfect square trinomial. Okay, and the one that it will be is x, and then it's half of this number. Okay, half of negative 6 is minus 3 squared. And the way that I get that perfect square trinomial is that the number right here is negative 3 squared, which is negative 3 times negative 3, which is plus 9. But I just added 9 to the equation, so to keep it equal, I must compensate for that by subtracting 9 over here. So it stays 0, but I get that 9 that I need to make a perfect square trinomial. Okay, and 3 minus 9 is negative 6. Okay, so the equation I get is y is equal to x minus 3 squared minus 6. The vertex is 3 comma negative 6. Okay, I changed the sign for x but not for y. And the axis of symmetry is going directly through this x coordinate of the vertex. I get x is equal to 3. So let's do some graphing. My axis of symmetry is right here at x equals 3. Okay, my vertex is at the point 3, negative 6 is right here. And let's plug in some points. Let's plug in x equals 2 and x equals 1. If I plug 2 into this equation, I have y is equal to 2 minus 3 squared minus 6. 2 minus 3 is negative 1. Negative 1 squared is a positive 1 minus 6 is negative 5. So I get the point 2, negative 5. 2, negative 5 is here, but it's symmetric, and so I get it over here as well. Okay? If x is equal to positive 1, plug that in, I get y is equal to 1 minus 3 squared minus 6. And let's see here, 1 minus 3 is negative 2. Negative 2 squared is a positive 4, and positive 4 minus 6 is a negative 2. So I get the point 1, negative 2, and it's symmetric, so I also get the point 5, negative 2 as well. Okay, now I'm going to go one more just so I have an extra term. And it's because it's pretty easy. And that is if x is 0, I can look up this equation right here. If x is 0, then I get positive 3. Okay, let's graph this. Something like that is the parabola. Something like this. Okay, now that's the parabola. I've not used red yet, so let's use red. Let's graph this equation right here. This is in y is equal to mx plus b format, and the y-intercept is this number right here, is 3. This is the y-intercept, which means this is one of my solutions. Okay, do I have any others? I don't know yet. The slope is negative 2, or negative 2 over 1. So if I go over 1, I drop 2. Over 1, drop 2. Over 1, drop 2. Over 1, drop 2. And I have 1 right here. That's also going to be a solution. Okay, let me draw the full line in. Okay, I will identify the solutions on the graph, and that is the point 0, 3, and the point 4, negative 5. Okay, and then I'm asked to solve this system of equations graphically. This is a 5 close parenthesis, by the way. Solve it algebraically, and I can do that, but I might need, let me try to fit it on the same page and not try to get it on a new page. Okay, now these are both equal to y, so I will substitute this right here in for this y. If I do that, I get negative 2x plus 3 is equal to x squared minus 6x plus 3. Okay, now this is a quadratic. I want to get one side equal to 0, so I add 2x to both sides, and I subtract 3 from both sides, and I get 0 is equal to x squared. Negative 6x plus 2x is minus 4x, and the 3 minus 3 cancels out, which is pretty nice. And I get 0 is equal to x times x minus 4. And so I get the solutions of x equals 0 and x equals 4, okay, which do agree so far. Okay, I'm kind of low on space. I'm going to erase this right here, this bit that I used to find the other coordinate points, to find the points that I need for my solution. So if x is 0, I'll plug that into the easier equation, which is this top one. Then y is equal to negative 2 times 0 plus 3, and that's equal to 3. So we get the point 0, 3, which looks familiar. And if x is equal to 4, then y is equal to negative 2 times 4 plus 3. Negative 2 times 4 is negative 8, plus 3 is negative 5. So I get the point 4, comma, negative 5, which again looks familiar. Okay, so whether you solve it graphically or algebraically, you get the exact same solutions either way. Okay, in 17, we're doing the exact same thing, except with a different system of equations. Let's complete the square for y is equal to x squared minus 4x minus 3. So again, I'm going to write y is equal to x squared minus 4x, leave a space, minus 3. Okay, and I want this to be a perfect square trinomial, and the one it's going to be is y is equal to x, and then half of negative 4 is negative 2 squared. And the way that I get that perfect square trinomial is if this term right here is negative 2 squared, or negative 2 times negative 2, which is a positive 4, but I just changed that equation by adding 4. So to compensate for that, to keep it equal, I will subtract 4 on this side, okay? And then negative 3 minus 4 is a negative 7. This is the equation in vertex form. Okay? And the vertex will be I change the sign for x, but not for y. Okay? And the axis of symmetry is going through this x coordinate. I get x is equal to 2. Okay? So drawing that in, it's right here. Okay, so plotting some points, I have the vertex at 2, negative 7, right here. Okay, plugging in x equals 1, then I get y is equal to 1 minus 2 squared minus 7. And negative 1 minus 2 is negative 1. Negative 1 squared is positive 1. Minus 7 is negative 6. So I get the point 1, negative 6. 1, negative 6 is right here. But it's symmetric, so I get the one on the right side as well. Okay. Now, on the y-axis, it's even easier because I can pull that off from this expanded form, and it's right here. So it's negative 3. Let me show you that. If x is 0, I get y is equal to 0 minus 2 squared minus 7. 0 minus 2 is negative 2. Negative 2 squared is 4, and 4 minus 7 is negative 3. So I get the point 0, negative 3, and 0, and then it's symmetric, and so I get the same point on the right side as well. So let me kind of sketch that graph. Okay. So let me graph this line right here. It is in y is equal to mx plus b format, okay, where the y-intercept is at negative 3, which is right here. So that's one of my solutions right there. And the slope is 1. So if I go over 1, I go up 1. Over 1, up 1. It's like this. It looks like this right here. Ooh, I don't know that exact point because I didn't find that point. So let me go back here, and let's find where it's supposed to be. Let's plug in x is 5. If x is 5, then I get y is equal to 5 minus 2 squared minus 7. 5 minus 2 is 3. 3 squared is 9. 9 minus 7 is equal to 2. So it is this point right here. Whoops, let me go red. It is right here, is one of my solutions. Let's draw this whole line in. Okay, so the solutions are 5, 2, and 0, negative 3. Okay, if we were to solve this algebraically, I'll do it the exact same way as before. I'm going to plug this top equation in for this y, and I get x minus 3 is equal to x squared minus 4x minus 3. Okay, this is a quadratic. I want to get one side equal to 0. So I'm going to subtract x from both sides. Actually, I don't want that color. It's too light. Subtract x from both sides, and I'll add 3 to both sides, and I get 0 is equal to x squared. Negative 4x minus x is negative 5x. The negative 3 plus 3 cancels out, which is really nice. Okay, and then I can factor this with the GCF of x, and I get x minus 5. Okay, and so I get x is equal to 0, and x is equal to 5. Okay, now to find the corresponding points, it's actually right here is where that work is done. Okay, and so I see that I get the exact same points. I get 0, negative 3, which is the same as that, and I get 0, not 0. I get the point 5, 2. Okay, so you can solve this either graphically or algebraically, and you find the same solutions. Okay, no calculator. Consider the polynomial function, and there's that polynomial function. Okay, determine the y-coordinate, the y-intercept, and sketch the graph of the function. Well, I can find the y-intercept by plugging in f of 0. Okay, so plugging in 0 into x, let me put this in a bigger parenthesis, 2 times 0 minus 1, 0 plus 4, and 0 minus 2. Okay, so 2 times 0 is 0, so I just get negative 1. 0 plus 4 is 4. 0 minus 2 is negative 2. Negative 1 times 4 is negative 4. Negative 4 times negative 2 is a positive 8. Okay, so the y-intercept is positive 8. One thing not asked about that we need to figure out to graph this is the x-intercepts. Okay, and I can find that by putting each of the factors equal to 0. So I have 0 is equal to 2x minus 1, and I will solve for x, and x is 1/2. Okay, that's one of them. From now on, it gets pretty easy. So what number plus 4 is 0? It's negative 4. And what number minus 2 is 0? And I get x is 2. Okay? All right. So I'm going to put in, make a little grid for myself. Not the most equally spaced, but it'll do. So putting in those x-intercepts, I don't want it to be that skinny. There we go. And negative 4, 1, 2, 3, 4. And x equals 2, I get that point right there. Okay, and it's negative 4, 1/2, and 2. So, and then the end behavior as well, end behavior. So the leading term would be 2x times x times x. The leading term is going to be a 2x cubed, which is positive and odd. And so I will end up, and I'll start down. So I will start down at the bottom, and I go positive, and then it goes down, and then back up, it'll end up. That's very generally what the graph looks like. And my x-intercept right here is at 8. So now that I have a sketch of the graph and all that, for what values of x is the function bigger than 0? So when is it positive? And it's above the x-axis between negative 4 and 1/2, and also after 2. Okay? That's when it's above the x-axis. Okay? What is the end behavior? Well, as x goes to negative infinity to the left, it's going down. Right? So it looks like one of these two. And as x goes to positive infinity, it's going to positive infinity, so it's this one right here. Okay, how many relative maximums does it have? It has 1 right here, so it has 1. Number 19, consider the polynomial function p of x is that. Okay, given that p of 1 is 0 and x minus 3 is a factor of p of P of x. List all the factors and zeros of P of x, and remember that P of x is a fourth degree polynomial. Well, I don't think I can do any factor by grouping here. So my first approach is to try synthetic division, okay, to divide this down where it's more manageable. And they give us 2 of the factors to kind of help us get it down there. So synthetic division, dividing 1 or x minus 1, the leading coefficients for my P of x is 1, 2, negative 13, negative 14, and 24. Okay, so synthetic division, bring the 1 down. 1 times 1 is 1. 1 plus 2 is 3. 1 times 3 is 3. Negative 13 plus 3 is negative 10. 1 times negative 10 is negative 10. Negative 14 minus 10 is negative 24. 1 times negative 24 is negative 24. And then 24 minus 24 is 0, which is what should happen because they said that P of 1 is 0. That's the remainder. Okay, now I have a third degree polynomial, but they've also given me this other one, that x minus 3 is a factor, so I will just keep going and divide that by positive 3 by changing the sign, negative 3, into a positive 3, so I can make that one change. So bring the 1 down. 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is 18. Negative 10 plus 18 is 8. 3 times 8 is 24. And negative 24 plus 24 is 0. Okay, so 0 is the remainder. It's a factor. Okay, and now I have a quadratic equation. It's 8 and then 6x and then x squared. So I get is, it's over here, is I get x squared plus 6x plus 8. And this is factorable. Okay, I get, this is the simple ABC method. What two numbers multiply to be 8 and add to be 6? It's plus 4 and plus 2. So all of the factors are, so starting with this one, I get x minus 1. I then get x minus 3. And the 2 I found down here, x plus 4 and x plus 2. Okay, the zeros I get are the numbers I plug in to get equal to 0. I can just kind of find it for each of these factors. What number minus 1 is 0? That's 1. What number minus 3 is 0? That's 3. What number plus 4 is 0? That's negative 4. And what number plus 2 is 0? And that is negative 2. Okay? So I'm now supposed to sketch a graph of y is equal to p of x and label all intercepts and indicate any relative max or mins. So I hope there's enough space at the bottom there for me. Kind of just give some a scale for the x-axis. Okay, now my zeros that I've already found are positive 1 and 3 and negative 4, 2, 3, 4, and negative 2. And the colors change on me, hold on. Okay, negative 4, negative 2, 1, and 3. Okay, what else do I got? Let's look at the end behavior. The end behavior is x to the 4th. Okay, that is even and positive, so I'm going to be up, up. I'm going to start up, and all this is a multiplicity of 1, so start up. I cross, I cross, and I cross, and I cross. Okay, now I've not labeled my y-intercept right here, but it's going to be 24. Okay, and I have relative, there's a relative max, and I have 2 relative mins. All right, number 20. Solve each radical equation and check your solutions. Box your final answer. Okay, so the first step is to solve, is to get the radical by itself, which is already done for me. That's very kind. So I'll square both sides, and I get 18 minus 3x is equal to x squared. And this is a quadratic equation, so I will get one side equal to 0 by, I'll add 3x to both sides and subtract 18 from both sides. And I get 0 is equal to x squared plus 3x minus 18. This is factorable. And so the two numbers that multiply to be negative 18 and add to be positive 3 is positive 6 and negative 3. Okay, so using the zero product property, what number plus 6 is 0 and x is negative 6, and what number minus 3 is 0 and x equals 3. Now, I can't box those and be done until I check for extraneous solutions. Okay, so plugging those back in, square root of 18 minus 3 times negative 6, does that equal negative 6? And the answer is probably not, because the right-hand side it says equals negative 6. So let's just keep going here. I have 18 plus 18. Does that equal negative 6? I get root 36, which is 6, which is not equal to negative 6. This is an extraneous solution. So checking the other one, I get the square root of 18 minus 3 times 3. Does that equal 3? Well, 18 minus 9. 18 minus 9 is 9. And root 9 is 3. And 3 equals 3. So this is my solution. Okay? Now, in letter B, there's two radicals. Okay, but that's okay. I can square both sides and they both go away. And then I get 8x minus 14 is equal to 6x plus 18. Okay, and I'm just solving this equation. I will subtract 6x. I'll move the smaller x, and I'll move the 14 on this side. And I get 2x is equal to, because that cancels and that cancels, 32. Okay, so let's divide both sides by 2, and x is equal to 16. So, does that work though? Let me plug it back in to check my answer. 8 times 16 minus 14, is that equal to square root of 6 times 16 plus 18? Okay, 8 times 16 is 128 minus 14. I get root 114. And 6 times 18 is 108 plus 18. Okay, I'm sorry. 6 times 16 is 96 plus 18 is 114. So those are equal. All right, letter C. Again, I solve for the radical, and it is, which is very nice. And I'll square both sides. Okay, and I get x minus 2 is equal to x minus 4 times x minus 4, because that's what it means to square a binomial. And I will distribute x minus 2 is equal to x squared minus 4x. Negative 4 times x is negative 4x, and negative 4 times negative 4 is a plus 16. Okay, so combining like terms, x squared, combining these two together, I get negative 8x plus 16. Now, to get everything on one side, I will subtract x from both sides and add 2 to both sides, and I get 0 is equal to x squared minus 9x plus 18. And this is factorable. Okay, so I need two numbers that will multiply to be 18 and add to be negative 9, and that is negative 6 and negative 3. Okay, so using the zero product property, I get x is equal to 6 and x is equal to 3. Okay, plugging both of those in, let's see if any of them work. I have 6 minus 2. Is that equal to 6 minus 4, right? Yeah, okay. Square root of 4, does that equal to 2? And 2 is equal to 2, that's true. This is a solution, okay? Plugging in 3, I get the square root of 3 minus 2, and is that equal to 3 minus 4? Well, 3 minus 2 is 1. Does that equal 3 minus 4 is negative 1? Is 1 equal to negative 1? No, it's not. This is an extraneous solution, and so my answer for 20C is the number negative 6. Oh, I never went back and boxed 16. I should have. Okay. All right, that is it. Okay. I hope this review video is helpful for you. Again, do your best to try it on your own, check your answers, and then use this video. Okay. Good luck studying for semester exams. I wish you the best. Thanks for watching.